Good morning. Let's continue on our example that we started last lecture. So last lecture we said we need to determine all of the electrical quantities in this circuit, and we mean by the electrical quantities all of the voltages and all of the currents. So the first step, we need to label all of the current directions and voltage polarities, and we already know how to do this. Basically, start from the source, so the current will go out from the source, then the current will be distributed. So for example, the current starts I source from the source 100 volts, then at node B it will be distributed to be I1 and I2. Then when you're assuming the voltages, keep in mind you need to satisfy Ohm's law such that Ohm's law is positive, so the currents will enter the positive sign of the voltage polarities. Therefore, we assume V1 such that the current enters the voltage, V2 the current enters the positive polarity of the voltage, V4 like this, the current enters the positive, and V2 like this. So all of the currents have been assigned and all of the voltages have been assigned to satisfy Ohm's law, to make it positive, while the source, it is something different, so the current will be out from the voltage of the source. Okay. Now, the next thing is start from the extra given information. No other extra given information here, so we don't know how to start. So basically, there is no additional voltage measurements, no additional power, no additional current measurement. So in this situation, locate the source. So look at the source and try to apply KVL, KCL, or Ohm's law such that there is only one unknown. So one of the ways that we mentioned, one of the colleagues here mentioned that we need to find R equivalents. So if we find R equivalent, we can find the source current, and this is a great idea. So how can we do that? We need to find R equivalent with respect to the source. So here, we just disconnected the source, and we need to find R equivalent with respect to the source. Now the question is how to calculate R equivalents. Basically, you need to label the nodes. So this is yellow node, then orange node, green node, and blue node. So how to find R equivalent? According to our procedure, you need to start from the furthest point, or the resistors that away from our observation. So the furthest point are the 8 ohms. Now, is there any relationship between 8 ohms and other resistors? Yes, with the 7 ohms. So what's this relationship, 8 and 7? Series. Why? Surely the same currents, exactly. So these two resistors are in series, yield 7 plus 8 equal to 15 ohms. Now we can redraw the circuits by making the simplification. So here is 4 ohms. Here is 10 ohms. Then the new resistance, which is the 15 ohms. Then relabel the nodes. We need to find our equivalents. So this is the blue node. Then we have the orange node. After that, the yellow node. So keep in mind, when you apply the series, some nodes will disappear. So the green node, since we did series, some nodes will disappear. While when you do the parallel, the nodes will remain. The number of nodes will remain. Okay, now I'm going to observe the 15 ohms. 15 ohms and 10 ohms, what's the relationship? Parallel. Why? Same two nodes, right? So 15 between orange and blue, 10 between orange and blue, right? Then these two are in parallel. How to calculate our equivalents? So we will say that 10 parallel with 15, which is 10 times 15 over 10 plus 15. This is a shortcut. If you want to use 1 over r, that's fine. You are free, do whatever you want, but I prefer to use this as a shortcut. So their equivalent will be, I think, 6 ohms. So the answer will be 6 ohms. Then redraw the circuit. This is 4 ohms. Now they're equivalent 6 ohms. Then we need to calculate our equivalent here. Let's relabel the nodes. It's basically, we can know those are in series, so you don't need to label the nodes. So I'm just, for clarification, I'm doing this simplification. Sometimes you don't need to over justify. Just draw the circuit, and if you figure it out without over justifying it, it can be fine. So you can locate at the new circuit here. The number of nodes does not change. They're remaining. Yellow, orange, blue. So when we do the parallel, the nodes number will not be changed. But when we do the series, some nodes will disappear. That's like what we did with the 7 and 8 ohms. The green node disappeared. So just like keep this for your information. Therefore, basically we can see that R equivalent will be 4 plus 6, which is 4 and 6 are in series because they're sharing the same current and common in one node, which is the orange. Then we will say R equivalent will be 4 plus 6, which is 10 ohms. Okay? Now I'm not done yet, so I just did first part of this question. So let's go back to the original. We just calculated R equivalent, then let's go back here, substitute R equivalent as 10 ohms. Then continue your question, your answer. So I source equal V source over R equivalent. V source 100 volts, R equivalent 10 ohms, then it will be 10 amperes. Now I know I source. So let's start from the source toward the other thing. So we just calculated I source. V source, we know it. We know V source. We just calculated I source. I source. Is there a way to calculate V1? Let's look. Is there like KVL, KCL, or Ohm's law such that there is only one unknown? Ohm's law, right? We know I source. We know the currents. We know the resistance. Then we can apply Ohm's law. So basically, we will say that Ohm's law to calculate V1, which is I source times R1. I source 10 amperes, then R1, which is 4. So the answer will be 40 volts. Now I know V1. So I'm done with this element, done with this element. Now let's look at this element. Here with this element, is there a way to calculate the currents? I don't think so, because if we want to apply KCL at node B, you will see that I source is known, I1 is unknown, I2 is unknown. So these are unknowns. Then I don't think it's a good idea to do KCL. How about Ohm's law? If I do Ohm's law to calculate V2, applying Ohm's law here. Ohm's law V2 equal I2 times R. We know R, but I2 we don't know it. So I don't think Ohm's law is a good idea. How about KVL? Let's see. If we apply KVL at this loop, V3 is unknown, V4 is unknown. So how about the other loop? KVL here. We know V source, we know V1, then V2 is the only unknown, right? Then that's it. That's the way that we think. Okay. So let's do KVL, and I'm gonna label the loop as loop 1. So don't forget to label the loop in your circuits when you will do apply KVL. So KVL at loop 1. Please make sure to justify your answer. Make sure that you need to know where are you applying your KVL. Okay. Then start from the left bottom corner, then go counterclockwise. So here we will hit the negative sign. So it will be negative V source, then positive sign, then positive sign, then that's it. So basically, it will be as negative V source plus V1 plus V2 equals to 0. Now you need to learn how to use this in fast way. Okay? Now substitute the values. Vs, we know it as negative 100 volts. V1 we just calculate it as 40 volts. V2 is unknown, equals to 0. Therefore V2 will be 100 minus 40, which is 60 volts. Therefore V2 equals 60 volts. And that one V1 was, and I1. Because we need to find everything, then we need just, I'm gonna box all of the answers. Okay. Now we know V2. How to calculate I1? Ohm's law, right? So we can do Ohm's law. So such that I1, or actually V2, equals I1 times R2. Therefore, I1 will be V2 over R2, which is going to be as 60, and R2 is 10 ohms, so the answer will be 6 amperes. Okay? I1 equals 6 amperes. So what should I do next? Okay, let me pause a little bit so you can write. And I will go. Let's go to the circuit. We know I source, we know I1. We know V2, we know V1, we know V source. Now there's still three unknowns, I2, V3, V4. So what do you think we need to do next?
KCL, B.
KCL, so we can calculate I2, right? So let's do KCL where? At node B. That's it. Because when we do KCL at node B, I source is known, I1 is known, then I2, this is the only unknown thing. Then, at node B, we need to apply KCL. So, I source is entering. I1 is leaving, I2 is leaving. So that's what we need to keep in mind. Therefore, when we do KCL, keep in mind you need to write where are you applying your KCL. So, at node B. So, which is the sum of leaving currents equals to 0. I source is entering, so negative I source. I1 is leaving, plus I1. I2 is leaving, plus I2 equals 0. Substitute the values I source, which is 10, plus I1 6, plus I2 equals 0. Therefore, I2 will be 10 minus 6, which is 4 amperes. I2 equals 4 amperes. Then that's it. We just calculated I2. What else do we need to do after calculating I2? Go back to the circuits. We still need to know V3 and V4. How can we find them? Ohm's law each one, right? So we will say Ohm's law for V3, which is I2 times R3. Then it's going to be 4 times 7, 28 volts. So V3 equal 28. Then the same thing, we can apply Ohm's law to calculate V4, which is I2 times R4, 4 times 8, which is going to be 32 volts. So V4 equal 32 volts. Then problem done. Don't forget to write the units. That's it. So we just calculated all of the voltages, all of the currents. Any questions? Okay. Now let's go to the next example. determine the power supplied by the source. Look at this surface. We need to calculate the power at the source. Where is the source? Locate the source. Here, 6 milliampere. It is current source. It's not voltage. Current. Now, how can we calculate the power supply?
R equivalent.
V times I, right? Now we need to determine the voltage polarities in order to determine if it is supplying positive or negative. Because remember that it is supplying or absorbing depending on the current direction and the voltage polarities. Like recall, if this element, if the voltage and the current going this way, so it is supplying. If the current go up or the current enters the negative, then it is absorbing.
Wait,
or
you just did
actually, I did the same, right? If the current enters the positive, then it is absorbing. If the current's leaving the positive or entering the negative, then it's supplying. Okay? So we need to calculate the power supplied by the source. Now the question is it supplying or absorbing? It's a source, so it should supply power. Okay? But we don't know the voltage direction. How can we assign? How can we do? Basically, assign it or assume a voltage polarity. So every time, recall this thing. I used to say, make the current leaving the positive every time when you do it for the source. It's the same for the current source as well. When you have a current source like this, make sure the voltage, the positive at the top of the arrow. That's a must every time. If you have the choice to choose the voltage or the currents, is a must to make your choice the positive at the top of the arrow, the negative at the tail. So the positive at the top, the negative at the tail, I'm going to call it as V source. This I will call it I source. Okay? Does this make sense? What's the point of making this? In this situation, I can guarantee this element is supplying power because the current leaving the positive. Then I can guarantee P source supplied is positive. It's no longer negative. So I don't need to worry about the negative sign. So it will be positive I source times V source. Okay? Now, how can I calculate it? It is I source, which is 6 milli, 6 times 10 power negative 3 times V source. Remember, milli means 10 negative power 3. It is very important to insert this milli. There are many mistakes that I used to see in the previous semesters, missing the milli. So the answer is correct, but missing the milli can change many things. So keep in mind, please make sure whenever you have milli, let me write it there. Milli means 10 power negative 3, kilo 10 power 3, then we have micro 10 power negative 6, while mega 10 power 6, we have nano 10 power negative 9, while giga as G 10 power 9. You need to know all of these. And there is pico. I don't think we will use it a lot, but just for information, pico as P lowercase 10 power negative 12. During the exam or the quizzes, if you struggle with, is this milli 10 power negative 3? If you missed it for any reason, then you feel free to ask. Okay? Ask me or the proctor or whatever who was. That's fine. You have the right to ask. But keep in mind, don't forget these. Let's go back to the question. Supplying power, it's positive because we make the positive or the current leaving the positive. Then it is I source times V source. So we know I source. The concern is how to find V source. How can I calculate Vs? Look at this circuit. How can I calculate V source?
The equivalent resistance.
Okay, let's find the equivalence. Then Ohm's law. Right. So basically, we can find equivalent resistance. So here is I source. Here is plus minus V source. Then here is R equivalence. Therefore, we will say that V source equals I source times R equivalence. And I source, as we know, it is 6 milli. 6 times 10 power negative 3 times R equivalence. Now the question has been transferred from calculating power to calculating V source, then now from V source to calculate R equivalence. So the only unknown that we have is R equivalence. How to calculate R equivalence? Redraw the circuit and label the nodes. And let's do it as usual. Okay? Does this make sense?
Yeah.
Let's do it. We need to calculate R equivalent here. Let's label the nodes. This is a node. This is a node. This is a node. And there is a node. Okay. Now, is there any simplification that I can do with this circuit?
The right side.
Yes. So what do we have?
So you can add those.
6 are in series, right? 12, 12 in parallel. So 6 plus 6 equals 12 kilos. 12 parallel with 12, let me write it here, means 12 times 12 over 12 plus 12, or in other words, it will be 12 over 2, so it will be 6 kilo ohms. So the next thing, I'm going to redraw the circuits and do these simplifications. So here, let me use 6 kilo ohms, 6 kilo ohms, 12 kilo ohms, here 12 kilo ohms. Okay? Label the nodes. The blue node remains and the green node remains as well. Pink node remains while the yellow node has disappeared, right? So what other simplification that I can do is 12 and 12, these two are in parallel. So 12 parallel with 12 means 12 divided by 2, which is 6 kilo ohms. Why I make it 12 divided by 2? Whenever you have R parallel with the same resistor R, this is equal R over 2 if R equal R. That's, if you want to use it, use it. If you don't want to use it, you can do the multiplication over the sum. Then the next thing, 6 and 6, series, right? 12, or 6 plus 6. Which is 12 kilo ohms. Then let's redraw the circuits with the new simplification. Here is 12 kilo ohms. Here is 6 kilo ohms. Then we still need to calculate our equivalence. Relabel the node or label the nodes. This is the purple and we have the green. Then basically 12 and 6 are in parallel. So 12 parallel with 6 means 12 times 6 over 12 plus 6. So The answer I think will be 4. 4 kilo ohms. This is our equivalence. Now, since I just calculated our equivalence, I'm ready to substitute it there. Okay, let's go here and substitute our equivalence. V source equals 6 times 10 power negative 3 times our equivalent. We calculated it as 4 kilo, right? 4 times 10 power 3 because it's kilo. 10 power 3, 10 power negative 3 will cancel each other. So 6 times 4, 24 volts. That's V source. Now I'm not done yet because I need to calculate the power. So let's substitute this here. So this will be 6 times 10 power negative 3 times 24. So the answer will be 144 times 10 power negative 3. What's the unit of the power? Watts. Don't forget to write this. As a shortcuts, we can write it as 144 milliwatts, or if you want, you can write it as 0.144 watts. Whatever you prefer, that's fine. And again, it's supplying power. Don't forget to write the units. So here is volts for the source. Power is watts. Current is ampere. Okay, any questions? Okay. Now I'm gonna talk a little bit about the power for different elements. Let's see if we have space here. Okay, I can take this corner. Okay. I will take this corner just to write something. We know that in DC, for the notation, V, I, and P, all of them are upper cases. We cannot say V, I, P, something like that, or lower cases. We will use upper cases. The power, as we know, it is V times I, right? Now, let's talk a little bit about the circuit elements that we have. So we have voltage source. We have also current source. We have resistor, inductor, capacitor. For voltage source, most likely we need to make sure the current is leaving the positive. Therefore, we will say that the power supplying is positive. Positive V times I. And if we talk about the absorbing, it will be negative V times I. Okay? Current source, the same thing. But keep in mind, in our notation, if we guarantee the current is leaving the positive polarity of the voltage, okay, then if we guarantee this, then it will be the same. Okay? The same as this one. Now, for the resistor, most likely we will assume the currents enters the positive polarity of the voltage, which is the opposite of the sources. So, in order to calculate the power, we know the power it is absorbing equal V times I, right? So this is the absorbing power. While the supplying equal negative V times I. So let me talk about the absorbing more. Equals V times I, right? So positive. Now we are all agreeing that the resistor every time are absorbing power. There is no way for the resistor to be supplying. So every time, maybe you can take it as a rule, when you calculate the power for the resistor, you can take the magnitudes without worrying about the signs and just make it, if you're calculating the absorbing, will be positive. If you're calculating the supplying, will be negative. You can take it as a rule if you want, or you can apply our methods, that's fine. But keep in mind, the final answer must be positive for absorbing. If not, then check your answer. And don't leave it negative, for example. If calculating the power absorbing for resistor and it is negative, then do this. Don't try the negative. Make it positive. Force it to be positive. Or change your answer to make it positive. Okay. Now we know Ohm's law, V equal I times R. So sometimes in order to calculate the power for the resistor, I don't need to calculate both voltages or the current and the currents. So one of them should be enough. So we can say that you can substitute them. So the power absorbing can be V times I, or it can be I squared times R, or it can be V squared over R. So it's enough to have one of these quantities, either the voltages or the currents, then you can calculate the power. Okay? Basically, by using Ohm's law, then you can skip one step. So you don't need to calculate all of the voltage. Most likely, in our circuit analysis techniques, we need to calculate the currents. So when you calculate the currents, the power will be I squared times R. That's my favorite formula. But I mean, we'll use everything. Keep this in mind. If you are still, for example, unsure which one should use, you can use V times I. So here, just I'm letting you know to use these techniques because these techniques are very important. Okay, how about the inductor and the capacitor? The inductor, we said it will be short circuits. The capacitor is open circuit. So the inductor, since it's short circuit, means the voltage equals 0. The capacitor, open circuit, I equals 0. P equal V times I, which means 0 times I, then therefore 0. For the capacitor, P equal V times I, and it's going to be V times 0, so the answer will be 0. This means no power consumed in DC or absorbed in DC. No power in DC. No power in DC. Because these elements, we already neglected them, replaced them by open circuit and the short circuits. Therefore, don't worry about inductors or capacitors. So whenever you see a DC problem and calculate the power being supplied or absorbed by this inductor, if and only if you are in DC, then directly you will say it is 0. You don't need to answer anything. Okay? But later in AC, it matters. And there will be something. There will be some values. In AC, these elements cannot be neglected. Any question? Now, let's focus, I guess since we're still talking about the power, about a theorem called Tilligence theorem. So Tilligence theorem says that the sum of the absorbing power by each branch or by all of the elements in this circuit must be 0. The sum of the power absorbed must be 0. Such that if that element is supplying, it will be, if it is supplying, then the absorbing will be the negative of the supplying. So it means when you calculate which is the power balance, the supplying and the absorbing must equal to each other. Since we let our reference as the absorbing, then whenever you see any supplying, convert it back to absorbing by put a negative sign. And that's it. So basically supplying should equal to absorbing. So when you move it to the other side, then power absorbed minus power supplied equals 0. So whatever, I mean, you don't need to do this, but I mean, just keep in mind, whenever you need to calculate the absorbing, it will be the negative sign of the supplying. Now, this is a question or this example which is show that the circuit satisfies Phillips theorem. So this circuit, we need to ask him if it satisfies Phillips theorem. Basically, we need to calculate all of the power and make sure all of the power absorbed equals to 0. So let's calculate all of the power absorbed for all of these circuits. This circuit is the same as the first example that we discussed in this class, which is example 1. It is the same as this one. So we need to validate. You can say like, let's add extra step for this circuit after calculating everything. We need to validate Phillips theorem by calculating the power for each element, supplying power for each element. Okay, so we have the values. So our first step is to calculate the voltages and the currents, and we already calculated them. Then that's good. That's great. So let's relabel on this circuit label the voltages. This is V source. This is I source. This is still I source plus minus V1. This is I2, or this is I1 actually, plus minus V2. Here is I2 plus minus V3 plus minus V4. In this circuit, actually, it is enough for me to know the current. So I would like to use I squared times R for the resistor. So I source, we said it is 10 amperes. And we said also I1 equals 6 amperes, I2 equals 4 amperes. Now I'm ready to calculate the power for each element. Okay, let's start with the source. So the power for the source absorbing, we know the source is not absorbing, it is supplying. Therefore, it will be negative V source times I source. V source, we have it as 100 volts. So it is negative 100 times 1 or times 10. So the answer will be negative 1000 watts. Or in other words, negative 1 kilowatts. That's the first element. The second element, which is to calculate the power for element 1, absorbing, I prefer, again, to use I squared times R. And since all of these resistors, then it will be positive. So it will be as I source square times R1. So I source, which is 10, square times R1, which is, we have 4. So the answer will be 400 watts. And it is positive. For element 2, absorbing will be I1 square times R2, which is going to be I1 is 6 times 2, 6 square times R2, which is 10. Then it will be 6 square times 2, 6 square, which is 30, 32? 36. Oh. 36 times 10, 360. 360 watts. Now, power for element 3 will be I square, now it will be I2 square times R3. And keep in mind, I put the absolute values because I just guarantee that it must be positive. I2 square times R3. I2 we calculated as 4 times 7. 4 square, which is 16, times 7, which is 112. 112 watts. Now P4 absorbed, this is the last element, will be I2 square times R4. Then it will be 4 square times 8, so it will be 128 watts. Now, I'm done. Check your answer. The sum of power absorbed must be 0. Now, is it 0? So let's see. Then, negative 1000 watts plus 400 plus 360 plus 112 plus 128. Then, this is of course equals to 0. Then, satisfied problem. Okay, so 400 plus 300, 760 plus 112, 112 plus 128, which is 240, 240 plus 360. This will be 4, 5, 600 plus 400 is 1000. So negative 1000 plus 1000 equals to 0. That's it. Okay? Any question? Okay, another example to calculate the power, which is, for example, number 2. Let's wait a little bit until make sure everyone is. Okay. Oh, actually, we done this one. This example. We need to calculate all of the powers. All the power till you see. This is the same circuit that we did in the second example. So V source, we calculated it as, where was it? It was 24 volts. I source, it is 6 milliamperes. For me, finding the currents is enough. We don't need to calculate all of the voltages. So basically, you can look at this circuit as, here is 12 kilo ohms, 12 kilo ohms, 12 kilo ohms, and this is a current source. So I source will split to these 3. So all of these 3 branches are equal to each other. Therefore, it will be splitted equally. This means it will split it as 2 milli, 2 milli, 2 milli. This happens if and only if they are equal to each other. Okay? 12, 12, 12. The current going there, it will split equally. As a ratio, it will be split equally. So that's why all of them are 2 milli, I1, I3, I5, 2 milli. Then let's look at the current here. So here is again 6 milli. This will be 2 milli, 2 milli, 2 milli. The other thing, which is what will happen here. So 2 milli is entering these resistors. So since here 12 and 12 are equal to each other, then it will be split equally, which will make it 2 divided by 2 milli divided by 2, 1 milli. So this will be 1 milliampere. This will be 1 milliampere. Now I know all of the currents. So let's put the values here. This is 2 milliampere. This is 1 milliampere, 1 milliampere, 2 milliampere, 2 milliampere, 2 milliampere. If you need to calculate the voltages, I times R, I times R. But actually, to calculate the power, there is no need to calculate the voltages. That's enough for you. Just knowing the currents and the voltage source. Now, let's start with this, to calculate the power for all of the elements. So let's start the power absorbed by the source. It is negative V source times I source, because its source is supplying power, which is going to be negative. V source is 24 times I source, which is 6 milli, 6 times 10 power negative 3. So the answer will be negative 144 times 10 power negative 3, or I will say it is negative 144 milliwatts. Okay? That's the first one. The second one, for P absorbed by element 1, which is going to be as I square, which is going to be called here I1 as a magnitude square, times R1. Then here, I1 is, we calculate it as 2 milli, 2 times 10 power negative 3 square times 6K, which is 6 10 power 3. Then the answer, after substituting this in the calculator, will be 24, and it is milliwatts. Okay? Milli means 10 power negative 3. Now, P absorbed by element 2, which is I O square times R2. Then it's going to be as 2, or it is 1 power 10 negative 3 times 12 10 power 3 So the answer will be 12 milliwatts. Now the power absorbed by elements, so we just did V1, this one, we did this, we did these three, then let's do V4, element 4, then we will back to 3 later. So for element 4, it will be as I2 square times R4, which is going to be 1 times 10 power negative 3 times 12, here squared, don't forget the square, times 12, 10 power 3, then it will be 12 milliwatts. Then after done with element 4, let's go to element actually this is not called element 4. V1, V2, okay. Let me call it elements VO. It's not written, I apologize about this. Let's do for element 4, element 3, which is for element 3, I3 square times R3. I3 square times R3, which is 1 times 10, 2 times 10 power negative 3, square times 6 times 12 power 3. So the answer will be 24 milliwatts. Now for element 4, which is here, we're done with this one. Let's do element 4, which is V4, times I4 squared times 6 kilo. P absorbed for element 4, I4 squared times R4, 2 times 10 power negative 3 square times 6, 10 power 3. So the answer will be 24 milliwatts. Okay, let's go back here. We're done with 4, then the last one, which is 5, I5 squared times R5. P absorbed by element 5 will be I5 squared times R5, which is 2 times 10 power negative 3 square, 12 times 10 power 3, so the answer will be 48 milliwatts. In order to validate telegens, the power, sum of the power absorbed must equal to 0. So here we have for the source negative 144, all of them in milliwatts, so plus 24, plus 12, plus 12, plus 24, plus 24, plus 48, all of it must equal to 0. If not, then your answer is incorrect. Validate or double check your answer to make sure it satisfies. If you, for example, during the quizzes or the exams, you realize it's not equal to 0, then just write a note. It's supposed to be 0, but I think there's something wrong with my answer. So we can make sure that you are understanding the concept, so you will not get a penalty of not satisfying this thing. The last thing, I just like to let you, I would like to write some textbook problems or homework problems that will be very important for the quizzes and for the exam as well. Textbook problems, which is problem 2.3, 2.4, 2.5, 2.6, 2.9, 2.10, 2.11, 2.27, 2.28, 2.31. Then, and also, I would like you to go to browse or go to worksheets. You can try at home, number 2 and 3. So these worksheets are important for your to complete your understanding. And the worksheets, you will see example that has been answered in details. Most likely, you might see a slight differences between the worksheets answers or the way or the procedure that the worksheet do and my procedure. So I encourage you to follow the things that we discussed during the class because it will make the class much easier. Any questions? Okay, so see you next week. Thank you.